Close your eyes for a second. Picture a mine. Not a small one, a massive, open-pit operation where the ground has been carved so deep that you can barely see the bottom from the rim. A place where the air tastes like diesel and iron, where the ground shakes when the machines move, where the sun barely reaches the floor because the walls of Earth rise so high on every side. Now, picture a machine at the bottom of that pit. It's not small. It doesn't move fast. But every time its arm swings forward and that enormous bucket bites into the wall of rock and soil in front of it, the Earth gives way. Not slowly, not reluctantly. It gives way completely, in massive chunks, like the ground itself has accepted that resistance is pointless. That machine is a Cat 385C front shovel, born in 2003, built for high-production mining, designed with one mission and one mission only: to move material faster, harder, and more efficiently than anything that came before it. This is the story of a machine that became a legend, and the legend that became an obsession. Stay with me, because this story goes deeper than you think. By the early 2000s, the global mining industry was under enormous pressure. Demand for raw materials, coal, copper, iron, or gold, was accelerating at a pace that existing equipment was struggling to match. Open-pit mines were getting bigger. Excavation cycles needed to get faster. Production targets that once seemed ambitious were now considered the baseline. The problem was an effort. Mining crews worked around the clock, in conditions that tested both men and machines to their absolute limits. Extreme temperatures, abrasive materials, uneven, unstable ground. Continuous heavy loading cycles that pushed hydraulic systems and mechanical components to their breaking point. What the industry needed wasn't just more machines. It needed a smarter machine, a more powerful machine, a machine that could handle the brutality of a real mining environment, not a controlled testing field, and keep performing at peak capacity, shift after shift, month after month. Caterpillar had been building heavy equipment for decades. Their engineers understood mining environments the way surgeons understand the human body, not just a theory, but the real-world complexity. The unexpected failures, the conditions that blueprints don't capture. And in 2003, they answered the industry's call. The Cat 385C front shovel entered the world. And mining was never quite the same again. Let's talk about what this machine actually was, because the numbers alone tell a story. Total operating weight, nearly 200,000 pounds. That's roughly the weight of 16 fully loaded school buses stacked on top of each other. And this machine carried all of that weight across the floors of active mines without flinching. Total length with arm fully extended, 46 feet and 9 inches, nearly half the length of an American football field, stretched out from the rear of the machine to the tip of the bucket. In a mine pit, that kind of reach is not a luxury. It's the difference between reaching productive material and wasting time repositioning. But the dimensions were just the beginning. At the heart of the Cat 385C sat one of the most capable diesel power plants Caterpillar had ever installed in a mining excavator. The Cat C18 engine, equipped with CERT technology. This wasn't just a powerful engine. It was a sophisticated, precisely managed system designed to deliver maximum performance while meeting the emission standards that were tightening across the industry. The output, 530 horsepower. Turbocharged, water-cooled, and engineered to perform under kind of sustained, brutal load cycles that would destroy lesser power plants. When that engine ran at full demand, bucket cutting into hard material, hydraulic systems working at full pressure, tracks resisting the pushback of thousands of tons of earth, it didn't strain. It roared. A deep, resonant sound that you felt as much as you heard. The sound of controlled, purposeful power. And beneath it all, the machine stood on an undercarriage built in an X-frame configuration, a structural design that distributed the enormous weight of the 385 evenly across the full width of the crawler tracks. On uneven ground, on soft underfoot conditions, in rain-soaked pit floors, the X-frame kept the machine stable, planted, immovable when it needed to be, yet capable of repositioning with a precision that operators relied on completely. Other excavators rocked and shifted under heavy loads. The 385C stood its ground. Here's where the engineering story of the Cat 385C gets truly interesting. Size and power are impressive, but in a high-production mining environment, What separates great equipment from legendary equipment is efficiency. Specifically, how much useful work can be extracted from every drop of fuel, every hydraulic pressure cycle, every swing of the arm. The engineers at Caterpillar understood this, and they built the 385C's hydraulic system accordingly. The front linkage, the system of arms, pins, and hydraulic cylinders that control the movement of the boom, stick, and bucket, was designed around a parallelogram geometry. This might sound like a technical detail, but its effect on real-world productivity was profound. In a standard excavator working in loading mode, the angle of the bucket changes as the arm swings through its arc. The operator has to constantly make micro-corrections to maintain proper bucket angle, which adds time, adds mental load, and introduces the risk of imperfect loading cycles. The parallelogram linkage on the 385C eliminated this problem. As the arm moved through its full range of motion, the bucket automatically maintained its position parallel to the ground. It didn't matter where in the arc the arm was. The bucket stayed level, stayed positioned for maximum penetration, and stayed ready for clean, efficient loading. What this meant in practice was remarkable. Operators could focus entirely on the primary movements, the boom, the stick, the swing, without worrying about bucket angle correction. Penetration into hard material was cleaner and more consistent. Loading cycles were faster, and the ground beneath the machine was left in better condition after each pass, reducing secondary cleanup work. And the bucket itself? A bottom-dump configuration capable of holding 7.5 cubic yards of material per cycle. In weight, that translated to over 10 tons per single pass. Every swing, every cycle, 10 tons moved, loaded, and gone in a 12-hour shift. The numbers that accumulated were staggering. Ask anyone who operated the Cat 385C in a real mining environment what it was like, and they'll pause before they answer, not because the experience was hard to remember, because it's hard to describe. There's a quality that separates truly exceptional heavy equipment from merely good heavy equipment. It's not one thing. It's an accumulation of small details that add up to something larger. The way the hydraulics respond to the joystick with no lag and no uncertainty. The way the machine holds position on a slope without constant correction. The way the cab insulates the operator from the vibration and noise of the working environment enough to maintain focus across an entire long shift. The 385C had all of it. The cab was positioned high on the superstructure, giving operators a commanding view of the work area. Visibility was critical in a loading environment. The operator needed to see the face of material being excavated, the position of the haul trucks waiting to receive the load, and the position of the bucket at every point in the cycle. Poor visibility killed productivity. The 385C's cab design minimized blind spots and maximized situational awareness. Inside, the operator station was designed around the human being, not as an afterthought, but as a central design priority. Because Caterpillar understood something that not every equipment manufacturer fully grasped. A fatigued, uncomfortable operator makes mistakes. Mistakes slow production. Comfort and ergonomics are not luxuries in a high-production mine. They are productivity tools. Shift after shift, the 385C delivered. In coal mines, in copper operations, in iron ore pits, across continents and climates and conditions that range from the freezing cold of northern Canada to the baking heat of Australian outback operations. Wherever rock needed to move, the 385C moved it. Let's put the performance of the Cat 385C in perspective with some numbers that are hard to argue with. A single operating cycle, from bucket penetration into material, through full loading, swing to haul truck, dump, and return swing, takes between 20 and 30 seconds under optimal conditions. In that time, over 10 tons of material has been removed from the mine face and deposited into the waiting truck. Run that cycle continuously across a 10-hour production period, and the productivity numbers become extraordinary. Thousands of tons of material moved, shift after shift, day after day. The machine's 530 horsepower engine, channeled through the precision hydraulic system, converted fuel into useful work with an efficiency that minimized operating costs per ton of material moved, which is ultimately the number that mine operators care about most. Total machine length at full extension, 46 feet 9 inches. Total operating weight, nearly 200,000 pounds. Bucket capacity, 7.5 cubic yards, over 10 tons per cycle. Engine output, 530 horsepower with CERT emissions technology. Undercarriage, X-frame design for maximum stability across all ground conditions. Each one of these specifications wasn't chosen randomly. Each was a result of engineering decisions made by people who had spent careers understanding exactly what mining environments demanded and exactly what it took to meet those demands without breaking down, without slowing down, and without compromise. The CAT 385C was not a machine built for test results. It was built for mines. Real mines, with real ground, real loads, and real consequences when equipment failed to perform. Now here's where the story takes an unexpected turn. 9 years after the CAT 385C first entered service, a different kind of tribute was paid to this machine. In 2012, Classic Construction Models, known in the collector world simply as CCM, announced a project that would capture the full complexity of the 385C front shovel in die-cast metal at 1/48 scale. This was not a toy. This was not a simplified representation. CCM was known for producing some of the most precise, most detailed scale models of heavy equipment ever made. Pieces that collectors and industry professionals alike treated as works of art in miniature. The 385C model was no exception. Every major external detail of the full-size machine was faithfully reproduced. The cab featured a functional door. You could open it and see the operator station inside. The engine compartment opened to reveal a hand-detailed replica of the CAT C18 power plant, rendered at 1/48 scale with level precision that required you to look closely to appreciate fully. The entire front linkage, boom, stick, and bucket was fully articulated, replicating the real movement geometry of the actual machine. You could position the bucket at any point in the digging arc, and the model would hold the position. It moved the way the real machine moved. And the production run? Just 750 units. Worldwide. Total. In the collector market for precision die-cast heavy equipment models, 750 units is not a large run. The demand was immediate. Collectors from across the mining industry, operators, engineers, executives, enthusiasts, recognized what the model represented and moved quickly. By the time the dust settled, fewer than 65 units remained available. 65 pieces of a 750-unit run, representing a machine that changed the mining world. That's not just a collectible. That's a piece of industrial history, small enough to hold in your hands. When we talk about the legacy of the CAT 385C front shovel, we have to go beyond the specs, beyond the production numbers, beyond even the CCM model sitting behind glass in a collector's cabinet. We have to talk about what it proved. It proved that you could build a machine weighing nearly 200,000 pounds and make it responsive enough to be genuinely operator-friendly. It proved that raw power and precision hydraulics were not opposites. They could exist in the same machine, working together, amplifying each other. It proved that the X-frame undercarriage concept could handle real mining conditions without compromise, that the parallelogram front linkage wasn't just a theoretical efficiency gain. It was a real-world productivity multiplier that operators felt in their daily cycles. And it proved that Caterpillar's approach to CERT engine technology, meeting stricter emissions requirements without sacrificing the power that mining applications demanded, was the right path forward for the industry. The lessons learned in developing and refining the 385C fed directly into the machines that came after it. Engineers carried the knowledge forward. Mining companies built their production models around performance benchmarks the 385C had established. In that sense, the CAT 385C front shovel didn't just work in mines. It shaped the future of the machines that would follow into mines for years and decades to come. That is a legacy worth understanding. In the end, a machine is a collection of steel, hydraulics, wiring, and fuel. But the great ones, the ones that get remembered, that get replicated in die-cast at 1/48 scale, that get discussed decades after the production run ends, those machines are something more. The CAT 385C front shovel was born in 2003 in a world that was demanding more from its equipment than ever before. It answered that demand completely, without apology, without hesitation, with 530 horsepower of diesel purpose and a bucket big enough to swallow 10 tons of earth in a single swing. It worked in places where failure was an option, in pits when material was hard, the targets were aggressive, and the margin for mechanical unreliability was zero. And it delivered, shift after shift, year after year. And when it was time to honor that legacy, not with words, but with craftsmanship, 750 people around the world now hold a piece of that story in their hands. A 1/48 scale piece of history, precisely rendered, fully articulated, and nearly sold out. The mine floors that the 385C worked are still there. The material it moved became the steel in buildings, the copper in wires, the fuel that powered cities. Its work is everywhere, invisible, essential, and permanent. That's what great machines do. They leave marks that outlast them. The Cat 385C front shovel left its mark on the earth, on the industry, and on the people who were lucky enough to watch it work. Drop a comment below. Have you ever seen a Cat 385C in action? Or do you have one of those CCM models? I want to hear from you. Subscribe if you're new, because the machines we're covering next are just as legendary and just as impossible to believe. See you there.